welcome to the MONBUKAGAKUSHO video solutions. And in this examination solution, we still discuss about MONBUKAGAKUSHO. And in this, we will discuss Gakubu Math 2016 Part 3. So there's number 3. Okay, so let's look at the question first. It said that let A be a number with A unequal to 0, and the interval is -1, A, and 1, and be an arbitrary real number. Let fx is ax plus b. Moreover, let f to the power of 1 x equals fx, and f to the power of nx is f of f to the power of n minus 1 x, and the n is 4, 2, 3, 4, and etc. And fill in the blanks with the answers to the following questions. Number 1, it says that for f and x, we express f to the power of nx for n equals 1, 2, 3 in terms of a, b, x, n. Now this is where the fireworks started. This actually take me longer time to solve it. Okay, so let's just go through it. Okay, so we know that fx is ax plus b, right? When we want to find a pattern of something, we actually literally have to build patterns on how the functions will be done, right? So they say that f and x equals f to the power f times f to the power n minus 1. So if I make f to the power of 2, it will result into 2 minus 1, which is 1, right? And it is said that f1x equals fx. So this is f of fx. And remember that fx is ax plus b. So we have to insert this ax plus b into the x. So this is a of ax plus b plus b. And this is equal to a squared x plus ab plus b. Okay, now let's continue to f to the power of 3x. This is of course f to the power of f2x using the same pattern and the same way. Okay, so we know that f squared x is this, so we just change it into this, and we insert it to the ax plus b. So a of a squared x plus ab plus b plus b, this is equal to a to the power of 3x plus a squared b plus ab plus b. Same as the case for f to the power of 4. It is f of f cubed x. So we just change from ax plus b, the x is this answer, a cubed x plus a squared b plus ab plus b plus b. So this is a fourth x plus a third b, a cubed b plus a squared b plus ab plus b. Now you see here we have, we recognize a pattern. This a squared x from f squared x actually continue from a to the power of 1, a to the power of 2, a to the power of 3, a to the power of 4, and b always there. Meanwhile, ab is here. You see that this is a squared b plus ab. In here there is no ab, so we can say that a to the power of 0b, a to the power of 1b, a to the power of 2b plus ab, then a cubed b plus a squared b plus ab. So that is the pattern. By this time, we know that this formation of pattern of ab to the a to the power nb always increasing. So therefore, we cannot use direct pattern recognizing. The only thing that we can recognize is ax. We can say that the pattern for f to the power of nx, right, is actually a and x plus something, right? If we write the b here, so b, ab plus b, so this is the pattern, right? A squared b plus ab plus b, a cubed b plus a squared b plus ab plus b. Now you see that this pattern will continue, and let's suppose we have n, let's say we directly go to n. Okay, so in this part we have b times nothing. Then in here we got b 1 plus a, and here we got b 1 plus a squared, and here we got b 1 plus a squared, plus a squared plus a third. And remember, this pattern comes with the increasing n. When n is 2, we got a squared x plus ab plus b. So ab plus b, it is only have 1 here. When n is 3, we got a squared b. When n is 4, we got a to the power of 3. So therefore, we know that this will be increasing when we substitute n here. We got the final pattern of AB is a to the power of n minus 1, right? So we can say that this pattern of B will continue from 1, okay, plus a plus there's more a here, a squared, a third, a fourth, then a to the power of minus 2, and a to the power of n minus 1. So you know what I mean? When this n is 2, we got only a to the power of 1 in ab plus b. When n is 3, we got a squared b. So this is n minus 1. Okay, so you got the point here. So from this particular, we can see that this is actually a geometric series. So geometric series is different if you have ever known about arithmetic series. So arithmetic series is when you got 1, 3, 5, 7. It is add, okay, or subtract can. But if geometric, you have to multiply the, or it is called a ratio, while it is called the difference. For example, 2, 4, 6, 8. This is times 2, times 2, times 2. The ratio from 2 to 4 is 2. Why I call this a geometric series? Because 1 to a is multiplied by a, right? And you multiply it by a to become a squared. You multiplied by a is a to the third. Therefore, we understand that we can change this into a geometric series, right? And we can say that from this series is that, let me rewrite it, b of 1 plus a plus there. So the first unit is 1, the second unit is a, the ratio is a, because a divided by 1 is a, same as a squared divided by a squared divided by a is a, okay? So we can say that the geometric series, because this is add, it will be an infinite series of sum. So, it's not infinite, it's just until to the power of n. So it's just a geometric series. And from this, we can find the total value of this geometric series. Okay? Now, how do we know the formula? Because the geometric series of sum has two formulas, which is actually u1, the first unit there, and then r ratio to the power of n minus 1 and r minus 1, or u1 1 minus r n over 1 minus r. So we use this if the ratio interval is between minus 1 and 1. Okay, so it means that we know that the series is convergent. Well, actually it's a mistake. This is actually the real interval, while this actually used when r is bigger than 1, and this is used when r is less than 1. And we know that a is bigger than 1 because after 1, a, and this should be continue, right? Okay, so we use this formula. The first unit is 1, r is a, the ratio, and n minus 1 and a over a minus 1. Okay, so we change this b to multiplied by in the bracket 1 plus a plus in dot 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 until a to the power n minus 2 plus a to the power n minus 1, and we can change that into this one, b of a to the power of n minus 1 a minus 1. Now we can add to the real pattern. We say that this a to the power of nx of a to the power of nx plus b a to the power n minus 1 a minus 1. So this is the answer for number 1. Okay, yep, pretty much it should look complicated because this is how Gakubu is. It just elevates the question difficulty.